Hello everyone, I am Professor Rashna Mahule from MCA Department, Pirapote Patil College of Engineering and Management. And in last lecture, we have started with the divide and conquer algorithm. In that, we have learned how the divide and conquer algorithm works. Now today, we are going to take some examples of the divide and conquer algorithm. The first example here is the multiplication algorithm. Let's start with talking about this algorithm. So here we are started with the multiplication of n digit integer. Now here integer multiplication can be performed using a divide and conquer technique. Now here the decimal notation is just a shorthand for the linear equation. Now you can see here we are having the number that is 3754. Now it can be linearly represented by using the equation that is given here. That is 3 multiplied by 10 raised to the power 3 plus that is nothing but 3000. Then 7 multiplied by 10 to the power 2 that is 700. 5 multiplied by 10 that is 50, and after that we have 4 multiplied by 10 to the power 0 that is nothing but 4. So combinedly it creates a number that is 3754, 3754. This is what the linear equation here. But if we want to multiply two numbers which are having n digits, at that time here we have the different way of multiplying it. Now in traditional way we are having this type of multiplication where actually here the number is recursively multiplied. So here this procedure can be used recursively to reduce the multiplication of two integers here. So that is what here we have given two numbers, that is 2345 multiplied by 6789. Now we are knowing that every time we have to repeat the step, and before each step we have to put zeros here in the unit place, so that we are getting the actual value that is equal to this one. But here we have to multiply each and every digit recursively here. So we can shorten it by using the divide and conquer algorithm. Now for that here this algorithm, this multiplication is, these numbers are first divided into two parts and then we are going to convert it into a whole number there. So that is what given in this particular equation. This equation is given here, that is this one. Here we are going to multiply these four digit numbers. Before multiplying that we have to divide it into n by 2. Here n is nothing but 4 and the n by 2 is nothing but 2. Here each number will be divided into two parts, that is what the 2345 will be divided into two numbers, that is 23. First number is 23 and second part is 45. It is divided into two parts, that is n by 2, 23 and 45. This number, that is 6789, can be divided into again two parts, that is 67 and 89. And then we are going to apply some equation on that. Here it is the formula. We will see that formula in detail in next slide. Here we are using the multiplication of first 23 and 67. Multiply by 10 raised to the power 4. Now why we are using 10 raised to the power 4? Because we are having the number that is of the size 4. Here n is equal to 4. But in the previous equation, that is this equation, we are having 10 raised to the power 3 because it is a linear equation. But when we are multiplying two 4-digit numbers, we have to put the number that is 10 raised to the power 4 here. That is nothing but n here. So let's start with the algorithm, how the divide and conquer algorithm is applied on this multiplication algorithm. Now here, let us consider the multiplication algorithm which requires fewer single digit multiplication. We have given the integer number, and that integer numbers we are going to divide into parts, and then we are going to apply the divide and conquer rule on that particular numbers here. Now see here, we are having the equation. The equation is xy. That is, here x and y are the two numbers, and we are going to apply the n by 2 digit multiplications on these numbers. At that time we are having the equation. That equation is nothing but, here we have the actual AC 10 to the power n. That here this is what the total equation, but it is coming from this particular thing. Here we are going to divide this, that is a into 10 raised to the power n minus 2 plus b. Now here a and b are nothing but the division or the parts of your actual number. Then here it is multiplied by c to the power 10 c in multiply by 10 raised to the power n by 2. That is what n by 2 digit multiplication. Here c and d is nothing but the two parts of second number, that is y. So combinedly it will create the equation, that is AC to the power 10 AC multiplied by 10 raised to the power n plus AD plus BC multiplied by 10 raised to the power n by 2 plus BD. Now here what is given, that is AC AD plus BC. That AD plus BC is here that AD plus BC is using the identity here. So we can replace that AD plus BC into this particular identity. Now how we are going to perform divide and conquer rule? We have already divided that data into n by 2, n by 2. Now we are going to conquer it. Conquer means here we are going to find out the solutions for simple multiplications here. So let's start with the solution here. So here we are going to start with the first calculation, that is P1 is equal to AC. Now here the large problem is divided into smaller problems. That problems are P1, P2, P3, and then we are going to combine it into a single problem. So here P1 is nothing but AC, P2 is B multiplied by D, that is BD, P3 is A plus B multiplied by C plus D, and after that we are going to multiply these two numbers, that is xy, where we are going to put this P1, P2 and P3 here. So let's start with that equation. Here the xy multiplication of xy is nothing but P1 multiplied by 10 raised to the power n plus, here we have P3 minus P1 minus P2. That is nothing but this equation is written here. That is P3 minus P1 minus P2 multiplied by 10 raised to the power n by 2 here, plus P2, because P2 is nothing but BD here. Now let's start. Let's just see. We are going to explain about this particular problem by using that multiplication. Now here what is given, the two numbers are given, that is x is equal to 2345, y is equal to 6789, and here n is equal to 4, because these two numbers are having the value that is n digit. So here we have 4 digit in each number, so here n is equal to 4. Remember that the divide and conquer algorithms are working better when that data is divided into similar parts. So here we are having the similar number digits and that are nothing but 4, 4. Now here we will calculate P1. P1 is equal to AC and here AC is nothing but AC is A is 23 and C is 67. A is nothing but the half portion of X and half portion is B. This is A and this is B. That is, we are dividing that X into two parts, 23 and 45. Y is nothing but CD. C is 67 and D is 89 here. So that is what we have divided that data into two parts and then we are going to use it into our multiplication. So here we have P1 is equal to AC, that is 23 multiplied by 67. This is 23 multiplied by 67 and we are getting the value here. Now P2 is nothing but BD. BD means 45 multiplied by 89 and we are getting the value here. Now P3 is nothing but A plus B multiplied by C plus D. So here A is 23, B is 45, that is the half of portion of your actual values. Then here we have multiply by C is 67 and D is 89. So that is what we have given and we are going to calculate the value of that. So we have the value of P1, P2 and P3 and we can put these values into our bigger problem. So here P1, the equation is P1 multiplied by 10 raised to the power n, that is P1 value is 1541. Here this is what the P1's value. So here multiply by 10 raised to the power n is actually 10 raised to the power 4 here. So that is nothing but 15410000. After that we are going to place the values of P2, P1 and P2 here, P3, P1 and P2 here and multiply by 10 raised to the power n by 2. And plus we are having the last value, that is P2 here. And finally when we are combining all these values we are getting the value, that is 15920,205. It is very simple to calculate the numbers using the divide and conquer algorithm. If we are calculating that numbers by using the actual multiplication what we traditionally use, that is this one, it is recursively going for the it is going lengthy here. But when we are using the divide and conquer rule, we can perform that algorithm, that steps to each and every number there, having n digits. So that is what very simple here. We can go for single digit multiplications also here. It will go up to the single digit multiplication. So that is what here we can return the n digit integers into n by 2 digit multiplications here, right? So that is what the multiplication problem. Now we are going to learn about the another algorithm, that is the binary search algorithm. And the binary search algorithm is again using the divide and conquer algorithm here. So let's start with the binary search algorithm here. So let's start with the binary search algorithm. In binary search algorithm, we are having the array. That array, the binary search algorithm is actually used for searching a number into a sorted list. The requirement for the binary search algorithm is the array should be the ordered array. The array is having the elements from 0 to n minus 1 there. So of course when we want to search any number into the array, we are going to start with the first number and then we are going up to the n number. But here as the algorithm, as the array is sorted array, it is the advantage. Okay. So here we are going to start with the binary search. the binary search is having a big problem. That big problem is here we are having the array of ordered element. It may be of any size. A very big data is given in here. It can be sorted in a very simple small steps by using the binary search algorithm. So that is what the big problems can be solved by using the binary search. But the requirement is the array should be the sorted array. Now what is the process of the binary search algorithm? Here in binary search algorithm we are having the array and that should be divided into two parts. Now here we have the criteria for division of that is nothing but we have to choose one number. That number we have to search in and then we are going to check the less values and the greater values of that number. That is what here we are having the Here we have the figure. In this figure we are having a big problem. The size of that problem is n here, which is going from 0 to n. It may have thousands of elements in the array. Now here in binary search what we are going to search is nothing but here we are going to divide it into two parts by using some key value. Okay, so here the key value is actually the mid of your array. So we are going to find out the mid of the array. Then we are going to check the number is less than mid. At that time we are going to search in the previous elements of the array. If the number what we want to search is greater than this mid value, we are going to search in the next array, next elements of the given mid here. So that is what the big problem is divided into three problems, that is the problem 1, problem 2 and problem 3 here. Okay, so that is what here the working of binary search. If we are using the binary search, the actually half of the elements are skipped. So the complexity of that algorithm is very small, that is big O of log n. Whereas the complexity of multiplication algorithm is n square, big O of n square, because we have to multiply recursively in that algorithm. So that is what the complexities of these two algorithms. The actual algorithm is given about the actual algorithm for the binary search is here on the screen. Here we have the search algorithm and that is, see here, it is denoted by BS. BS is nothing but the binary search. After that here we have A, which is nothing but the array. Here we have the value, the letter n, that denotes how many elements are there in that array, that is the size of your array. Now after that x is nothing but here we are using that variable to check we are going to search that variable, that is nothing but x here. And after that here we have j, so that j is here we are using for finding out that particular element. So here we are putting that values into x here. Whenever we are going to find out the mid, we are going to place that mid into x, and whenever we got the actual value, that actual value will be stored into j here. Now let's start with that algorithm. Here we have the very first line is the initialization of variables. So here we have the local integer, that is low, high and mid. Now here low, high and mid are nothing but the positions of your elements, positions of your array values. Here we have low is initially 0. we are starting with the first element here, which is the start of your array. High is n minus 1, that is the last element of your array. And then we are going to find out the mid here. Now always we are going to check the while. While low is less than or equal to high, we are going to find out the mid. Now what is mean by that? Here we are having the value of low. Here we are having the value of high. When low, this is low, is less than or equal to high, at that time we are going to find out the mid. We are going to divide that array into two parts. Okay, so here in between we are getting the mid value. Okay, and here it is the left part and this is the right part. And then we are going to check the mid, the less than values and the greater than values here. So whenever we are having the low is less than or equal to high, we are going to find out mid, which is calculated by using the floor operator, low plus high divided by 2. Means here, suppose we are having the elements that is 0 to 5 or 6 suppose. At that time, we are going to find out the value. Low is 0, high is 6 here. So here we are having the value that is equal to 6 divided by 2. So that is nothing but the mid will be 3 here. Now suppose here we are having the value that is what? Low is 0, high is 5. So here what is the mid? Mid is 0 plus 5 divided by 2 here. Okay, and that is nothing but floor. The floor operator is used because it may have the value in floating. So that is what we are getting here. We are getting the value that is equal to 2.5. Okay, but 2.5 is not, it can't be assigned to an integer value. So here we are taking the floor of 2.5. So the floor of 2.5 is nothing but 2 here. So that is what we are calculating here. That is the floor of the low plus high divided by 2. Now we are going to check if x is equal to a of mid. If the value what we are searching for is equal to that mid value, then we are giving that value as a search value. Means our search is successful here. So we are giving that value in J and then we are returning from this algorithm. That is what our search is successful. In a single in the single search, in the single process, we are getting the actual value here. Now the second one, if it is not is equal to mid, so we have to go for at least for the left part or the for right part. If the value, the what we are searching, that x is less than mid, here if x is less than mid, we are going for the left part, and if x is greater than mid, we are going for the right part here. So of course less than or is equal to, greater than or is equal to operation we are going to use here. So that is what here we are having the next condition. If x is less than a of mid, then what we are going to use, what we are going to do, that is high is equal to mid minus 1. Now what is that? Now here we have suppose 0 and 6 element and we are searching for suppose 2. Suppose this is 0, 1, 2, 3, 4 and 6th element is there. Okay. So here we have the 6 elements and we are searching for suppose 2 here. We are searching for 2. So what will happen here? We are going to check the x. X is less than mid. Of course, when we find out the mid of that is 0 and 6. So the mid is 3 here. x is less than 3? Yes, the condition is true. So we are going to skip this particular portion and we are going for the left part here. So we will start with the 0 as low and 2 as high here. Okay, 2 as high means here we are having mid minus 1. Mid is 3 and we are just going less to that. This is n, this is mid and we are going for mid minus 1. That is nothing but 2 here. If we are searching for the number which is greater than 3, so we have to move for the right part of the array. So we will start, the low is the next element than the mid. So that will nothing but mid plus 1. So here we have to assign low is equal to mid plus 1. It will go up to 6. So here we have 4 as low and the 6 as high here. So whenever the data is less than mid, we have to change high. We have to change high here, and after that if it is not less than, it is greater than mid, at that time we have to replace it with low. And here we are having that algorithm. This algorithm is iterative algorithm. The complexity of that algorithm is given, that is the best case, average case and worst case. Okay, so the best case, average case and worst case. Best case means here it is nothing but big O of 1. In a single search we are getting the actual value, that is here we have the best case. If we are getting the value, that is average case is there, so that is nothing but here we have the big O of log to the power big O of log to n, log to the base 2n here, and the worst case is big O of log to the power log base 2n. So generally we are having the average case and worst case are similar here. So that is what the complexity of the binary search algorithm. Now here we are having the another algorithm, that is the recursive algorithm for BS, that is binary search here. So again in that we are having the integer RBS. RBS nothing but the recursive binary search algorithm. Here again we are having the array, that is A. Again we have the low, high and the actual search element, that is equal to X. Now this algorithm goes recursive. Recursive means RBS is calling itself multiple times depending on the condition. So what we have seen in last lecture, we are just replacing the variable there, that is low and high. Here we are calling the values, here we are passing the parameters to the actual function here. So let's start with this. Here we have local, that is integer mid. If low is greater than high, then we have to return. Okay, if low is greater than high means here we don't have any value, we have to return high plus 1 here. Okay, we have to go for the next element here. Now next is what we are going to find out. If it is not, then we are going to find mid is equal to floor of low plus high divided by 2, means we are going to find out the mid here. If mid is A of mid is equal to X, means the mid value is equal to the search value, we are going to return the mid here. If it is not, and if it is less than A of mid, we are going to change the values of here mid minus 1, means here whenever we are having the value which is less than mid, means we have to go for the left side of the list, means we have to change high here. High is actually the end value of your array, but when we are having the value which is in the left portion, at that time we have to skip the right part here. So here we will have mid minus 1. Okay, so that is what here we have. We are calling the values by changing we are calling the function RBS by changing the value of that. And if the value is greater than mid, then we are going to call here the again the function that is RBS, and here we are going to change low. Okay, so when the x, that is search value, is less than mid, we have to change high. If the search value is greater than mid, we have to change low here. So that is what the two algorithm, one is iterative algorithm and one is recursive algorithm here. Now we will see the actual example of that in the binary search algorithm. So here we have the example of binary search algorithm. Now see, here we have given the array of 8 elements. Okay, so it is the sorted array given. In that we have to search 20. The search element is 20. We can see that the search element is present at the 5th position. But we are not knowing actually when we are going to search the elements, we have to think about, we don't have to think about the positions, we have to search it by using the algorithms. So let's start with searching it. So first step is what? We have to find out the middle of the first time we are going to find out the middle. So what is happen here? Here low is equal to 0. High is equal to 8 here. Now see, low is equal to 0, high is equal to 8. So here we are going to find out the mid for that. Mid is nothing but here low plus high divided by 2, that is nothing but 4. So we got the position 4 here. Now we will check the conditions. The actual value is less than mid or greater than mid or is equal to mid. So here we are going to check the conditions. If 20, that is number to search, is equivalent to 15, which is the mid of what is the mid calculated by this first time? That is no. That condition is false here. This condition is false. So 20 is not equal to 15, means we have to go for the searching for less or greater. Now here we will check the second condition, that number to search, that is 20, is greater than 50. If it is greater, yes, it is true. So we have to go for the right side of the array. Means what? Here we are going to search 20. The 20 is greater than 50. It means we have to go for 20 will be on the right sub array here. That condition is true. So of course we have to skip this whole array here. Means in a single comparison we are skipping half of the element. You can imagine if we are using 10,000 elements here and we want to search for a single element, at that time 5,000 numbers are already skipped here in a single comparison when we are going to check for less or greater, when we are choosing the left array or the right array here. So that is what half of the portion is skipped here, and we are going to search our element into the right half. Now after that, here we have the step 2, because it is again having the array. So we have to go for again recursion in that. We have to again find out the mid of this array. So here we are having now array, this is the array, and now we are going to again find out the mid for that. So here the low is 5, the high is 8. So here we will have 5 plus 8 is 13. 13 divided by 2. Here we are going to find out 13 divided by 2. Actually it is nothing but 6.5, but here we have to use floor of that. So when we are going to use floor of that, so the value is nothing but the integer value, that is equal to 6. So the next mid what we got is the 6th position. So we are going to check the number is greater or less or is equal to mid. So we are going to check the condition. If 20 is equal to 25, no, 20 is not is equal to 25 means 20 is not is equal to mid here. Condition is false. So we will go for left or right here. So we are going to check the second condition here. If 20 number to search is greater than 25, it means 20 would be in the right sub array. So it is not. 20 is not greater than 25. So again this condition is false here. Now we will check the condition, that is if 20 is less than 25. Yes, 20 is less than 25. It means it will be in the left sub array. Means here we have to skip this particular part. Okay. So here we are remaining with only the single value. Okay. So now we are going to again find out the mid value for that. Here we have low is equal to 5, high is equal to 5. 5 plus 5 is 10, divided by 2 we are getting 5 here. Okay, that 5 is nothing but mid. Now we are going to check again the condition. The number is equal to mid. Yes, the number is equal to mid. The condition is true, and here the position of that mid is 5. Means 20 is present at the position 5. Okay, the index of the 20 number is 5 here. So that is nothing but we got our search is successful. We got the element at the position 5 here, at the index 5. Okay, so that is what the working of binary search here. So that is for today. In next lecture again we will see some of the different algorithms which are coming under this divide and conquer rule. Thank you.